At the end of the lesson, you are expected to access text corpora with Gutenberg Corpus using Python. Use Python to access text corpora with Gutenberg Corpus, and appreciate the Gutenberg Corpus in natural language processing. We know that words do not appear out of nowhere. In fact, they are a product of specific speakers or writers of a specific dialect of a specific language. So they are made at a specific time in a specific place for a specific purpose. So we had this in our discussion in our last topic about language corpus. So I'm going to give the description the link in the description below for you to be able to properly navigate and for you to be able to make this lesson more understandable. So when we say text corpus, it is a large body of text. Maybe at this point, the best question to ask is, how is a corpus designed? So generally speaking, a corpus or a corpora is designed in such a way that we can find a careful balance of material in one or more genres. So what is the meaning of this when we say careful balance? So let's consider a certain book about English literature. So this book may contain poems and short stories. However, you may find out that in some instances there are some words that are considered in the category of politics and law. They could be in business. They could even be found in the medical field. So these terms can be found in this book. But then, of course, careful balance or proportion with respect to literature terms is observed, because if medical terms, for example, overpower the literature terms as to number, then the book becomes a medical book and not an English literature book anymore. Okay? Did you get it? So before we continue, hit the subscribe button to enjoy more our deep learning, machine learning, and natural language processing lessons. Click the notification bell to receive more updates. We are going to examine a number of text corpora. We're going first to access text corpora using Gutenberg Corpus, but in our future lessons, we're going to have more. So maybe the first question that you would like to ask me is that, what is this Gutenberg Corpus? Well, let me highlight this one first. It is a fact that NLTK includes a small selection of texts from the Project Gutenberg Electronic Text Archive. So here, you can find some 25,000 free electronic books. So let's examine this corpus. So what we will do first is that we're going to get the Python interpreter so we can load the NLTK package. So we import the NLTK, as you can see in here. And then after we have imported NLTK, we are going to ask to see nltk.corpus.gutenberg .fields ID or that file IDs. The nature of this is that it is the file identifier in Gutenberg Corpus, this one, the Gutenberg.file IDs. So this is the identifier in Gutenberg Corpus. So these two actually can be just run simultaneously. So when you execute this, then you can find these ones. Okay, so you can find the different files in Gutenberg Corpus. So you can have, or we have, Austen Emma, Austen Persuasion, Austen Sense, even the Bible we have here, the Bryant stories, the Carol, and also we have here Shakespeare's like Hamlet, Macbeth, and we have Whitman Leaves. Okay, so after accessing these texts, it is time to examine the text in the corpus. So we will just consider one of them. So let's just have the first of these texts, which is Austin Emma. Okay, so this is Emma actually by Jane Austen. This is okay, Emma. I actually love Jane Austen. She has written lots of internationally well-known books like Emma. So Emma is one of my favorite Jane Austen's book. I love this novel because it changed the face of fiction with regard to form and technique. So you may read this novel should you have time, because it's really very interesting. So here we give it a name, Emma, here. So we have Emma, then we have the equal sign, then to access that. Then we are also very interested in knowing how many words this text has. So here, when you execute this one, we can find that Emma has 192,427 words. Okay? So we can also try this with other texts. Let's see. So let's copy this one. Let's copy this code. And let's try to use, let's have Shakespeare. Shakespeare. And let's have Shakespeare Macbeth. Okay, and we will find out how many words this one has. Okay, so, and then we will use here, oh, where are we? Oops, here, not there. I think, oops, we will go back first. Not there. Okay, it's here. It's supposed to be here. So, yeah, are we correct? Yeah. Okay, Shakespeare. Then, oops, sorry. It's not supposed to be there. It's supposed to be here. What's wrong? Okay. Then let's erase this one or delete. Then let's have Shakespeare. Okay, are we correct? Shakespeare. All right, then let's check how many words this text has. Let's execute this. Okay, so we have found out that Shakespeare Macbeth has 23,140 words. Okay, so you can actually do this one with other text files there. So examining a text is not only limited to reading. Am I right? Because usually when we would like to examine a certain text, we read. That is how we are taught in school. Okay, so we may want to identify that, or the every occurrence of a certain word together with some contexts. So in this case, we're going to use concordance. So let me do like this. Okay, so we can see. So as you could see here, we use here concordance. So what is that? So if we are going to execute this code, then we can have this result. So we have displaying 25 of 37 matches. It means to say that the word surprise here has 37 matches, but only in this case we have just displayed here, or it displays only 25 out of 37. Okay, so do you want to know the assumptions of this or these results? So the use of concordance assumes that we are using one of the texts obtained as a result of importing the books in NLTK. So here we perform concordancing for the word surprise. Okay, so that's it. So here we have her father was sometimes taken by surprise at his being still able to pity, and more and more and more. Okay, So if you have observed just a while ago, when we defined Emma, we invoked the words function. Let me go back to that one first. Emma. Okay, here, right? Because we would like to access to Emma, then we invoked the words function. Okay, so this kind of process can be cumbersome sometimes, but then the good thing is Python provides a simpler way to access the text file or text file IDs, and the way to do that is this. Okay, so now it becomes easier. So it's still the same case with respect to here. So we still access all the file IDs. So we have Austin Emma going to Whitman Leaves. Now, we may as well be interested in accessing the whole of the text. So we would like to read the whole of Emma. Okay, so for example, we're going to access Emma 2. Austin Persuasion text, which is here, text number 2. So using this, we can access to the whole text, which is a raw text. So when I say raw text, it means there's no tokenization involved, no normalization involved, just the plain whole text. So after we have accessed this one, the whole texts, then we are going to just focus on just only one text. So here we focus on Austin Persuasion, that text. So here we have access to it. Okay, so we have Persuasion by Jane Austen 1818. But then if you would like to really see the whole text here in our Jupyter, then we can use that raw. Alright, so as you could see, Persuasion by Jane Austen 1818. So this is actually the line that you could see in here. But in this case, we've accessed the whole of the text. So we have chapter 1, then Sir Walter Elliot of Kellynch Hall is in Somersetshire, was a man who, for his own amusement, never took up any book but the blah 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 and so on and so forth. So this is the whole text. So as you could see, if you're going to scroll this one down, okay, and okay, this is quite a lot actually. Alright, and also if we would like to know how many words this Emma Persuasion or Austin Persuasion has, then we're going to measure or to identify the number of words it has. So using this one, len Emma 2, then we could see that it has 466,292 words. Okay, that's a lot. So let's take something this time more interesting. So I think you and I would really love it. So let's consider a short program for us to know more about, or to know more information about each text. So what we're going to do is that we are going to loop over all the values. Okay, we're going to loop over all the values of file ID that correspond to the Gutenberg file identifiers. So here we have a short program to do that. So after this, we're going to compute some statistics for each text. So we have here our variable num chars, num words, num sense, and num vocab. So what are these? So we also would like to have a cleaner and compact output display. So for us to do this, we would round off each number to the nearest integer by using round function, as you could see in here. So we round the results. So of course our output would be more compact and cleaner. So this is our whole code. So we're going to identify the measure of characters, the measures of words, the sentences, and then the vocabulary. But then, when we execute this code, then we are given this output. So we have 5, 25, 26, then we have Austin, Emma, that text, 5, 26, 17, Austin, persuasion, text. So what are these? So examining our outputs, we can see we have 3 statistics. So we have the first column, the second column, and then we have the third column. So we have here our number 1 here in our first column. This is the average word length. And to compute that, what we did here was we divided numchars, this one, with numwords to find or to get the average word length, right? And then for our second column, this is actually the average sentence length. So a sentence for Austin Emma, the average length is 25 words. So how to get that? What we did was numwords divided by numsense. So numsense or numwords divided by numwords divided by numsense. And then we have this 25, okay? Then for the third one, which is the number of times each vocabulary item appears in the text on average. So this is actually what we call lexical diversity score. So maybe you would like to ask me before we go to the calculation, what is this lexical diversity score or lexical diversity? So when we say lexical diversity, it means the measure of how many different words that are used in a text. Okay, so and how to get that? What we did here is we divide numwords by the number of or num vocab to get this 26. So it means to say that in Emma we could see 20, at least 26 on average, 26 different words in a text. Okay? Okay, so for Austin persuasion, we have 5 for average word length. Then we have 26 for average sentence length. And then we have 17 for lexical diversity. So as far as the English language is concerned, we can say that average word length is a general property. So we can see that 4 is the recurrent value, right? Here we can see a lot of number 4. Okay, again we can see a lot of number 4. So maybe you would like to ask me, is it really true that in the English language words have 4 length or 4 word length? So in reality, however, the average word length is 3 and not actually 4. Why is this? The reason for the 4 here is numchars, variable, count, space as characters. So it is also notable that average sentence length and lexical diversity are the characteristics that are unique to a certain author. So this is actually understandable because each author has his own style. So for example, if I'm a writer and you're also a writer, so our styles in writing are different. So the way I make sentences is different from the way you make your own sentences and our own word choices. Okay, so we're going to have more. Let's make it more interesting. Let's use another one. So we are going to access the Bleak poems. So to do this, we use the raw function. So here we could see the whole text. Okay, And then, okay, so you have a lot of words. So we may as well be very much interested in how many words this text contains. So executing this, we could see that it has 38,153 words. Okay, and also we would like to use sense function to divide the text in separate to divide the text up into its separate sentences. So here each sentence is a list of words. So what we do is that we use the send function. But then sometimes we would like to be interested in some sentences or in a certain sentence. So from this list of sentences, we're going to, or we would like to know what is sentence number 15. So when we do that, we can see that sentence number 15 is from the morn to the evening he stays, he shall follow his sheep all the day, blah 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 blah. Or what if we're going to have number 10? What sentence is this? Sorry. Oops. Okay, so sentence number 10 is Piper, sit thee down and write in a book. Okay, lastly, we're going to have okay, number 2. What is sentence number 2? Okay, sentence number 2 is we have, okay, songs of innocence. Okay, that's the text number, sentence number 2. Okay, and also if we would like to know which sentence is the longest, then we can use this code. So in this text, our longest sentence is I fear that I am not like thee. So as you could see, it's very long, right? After all being said and done, let's try this. How do we access Gutenberg Corpus? Can you write short program to examine text in Gutenberg Corpus? Leave your answers in the comment below so we would be able to have a very rich interaction and exchange of ideas. Just click the video on your right screen to know more about this course. You can learn and upskill for free. We have courses in deep learning, natural language processing, and mastering machine learning algorithm. Share this with your friends.